Welcome students, both old and new students. Welcome to this lesson. This is Black Slides Online Secondary School, and I'm your teacher, Mr. Paul Chilola. Once again, welcome. Alright, so we meet now for a lesson in the Msce Form 4 Physics on a topic called radioactivity. Radioactivity. If you are new to the channel, let me specifically invite you to the channel, and also if you'd like to enroll for online lessons, don't hesitate to contact me on the numbers that have been shared here. Once again, you are most welcome. If you are watching this lesson on YouTube, which is the Black Slides Online Secondary School YouTube channel, consider liking the video, subscribing, and hitting the notification bell. That way you will do yourself some good, because it means you will receive lessons directly. Each time I upload a new video lesson, you are going to be the first one to know. You are going to be the first one to know. So like the video, subscribe, and hit the notification bell. Once again, Mr. Chilola is my name, your teacher on this platform. So like I said, welcome to the topic called radioactivity. Radioactivity, it's one of the last topics in your Msce Physics, all right? And it falls under the broad topic or branch of physics called nuclear physics. In Form 1, you learned that physics can be divided into different categories, into different branches, which I believe there are 6, and radioactivity is one of them. So like I always say, in order to unlock the understanding of any topic, it is important to define the terms that relate to that topic. All right, one such term that requires definition is radioactivity. Define the term radioactivity. In your paper 1 physics, your examiners can ask you to define the term radioactivity. So what is it? We define the term radioactivity as the spontaneous disintegration of the nucleus of unstable elements with the emission of radiations. All right, so let's look for keywords in the definition. All right, so we are saying radioactivity is a spontaneous disintegration. What does that mean? Spontaneous. Spontaneous means natural or occurring naturally. All right, you don't have to cause it. It occurs naturally. Okay, it happens naturally. So spontaneous disintegration. Disintegration means breaking down. When something is breaking down into parts, then that material is disintegrating. To disintegrate means to break down. But since the breaking down occurs naturally, we say therefore it is a spontaneous disintegration, happening without being forced. It occurs naturally. It occurs to nucleus, the nucleus of unstable elements. Some elements of the periodic table are not stable. They are unstable. What makes them unstable is the unequal numbers of protons and neutrons. Unequal numbers of protons and neutrons in the nucleus of atoms will make such atoms unstable. Due to that instability, the atoms, the nucleus, are going to break down. So that breaking down, the process of breaking down, is called radioactivity. So the breaking down of the nuclei is accompanied by release of radiations, which we are going to talk about shortly. Radiations. All right, so therefore we shall define, let me take you through the definition again. We shall define radioactivity as the spontaneous disintegration of the nucleus of unstable elements with the emission of radiations. So radioactivity releases radiations and it occurs naturally. All right. Another process related to radioactivity is radioactive decay. All right. You recall the word decay means what? Is breakdown. Yeah. So it's more or less like disintegration. It's a decay. It's breaking down. All right. So during radioactivity, a new element is usually formed. All right. So an element is going to change into another element. A new element, which is called a daughter element, is going to be formed from radioactivity. And the process is accompanied by emission of radiations from the nucleus. All right. So radioactive decay is the process by which an element changes into another element. So it's like an element which is called a parent gives birth to another element which is called a daughter element. Since the process is associated with releasing radiations from the nucleus, the entire process is called radioactive decay. I would urge you to know both definitions. The definition of radioactivity and the definition of radioactive decay. So, in relation to whether radioactivity or radioactive decay, we have three types of radiations which we are going to discuss. Namely, we have alpha particles, which is also a radiation, beta particles, and gamma. Take note that the first two, these two, are particles also. They are particles, But gamma is not a particle. It's not a particle. Gamma is not a particle. It's just radiation. It belongs to the types of radiations known as electromagnetic waves, which you also cover in Form 4. All right, in order for us to understand radioactivity, it is important to throw ourselves back to what we learned in Form 1. It's important to go back to the basics. All right, in Form 1, you learned, in chemistry in particular, you learned about the structure of an atom. Okay, you learned that an atom has three subatomic particles, types of subatomic particles. All right, you learned that the nucleus of an atom, suppose this is an atom containing electrons which are located in what are called shells or energy levels. All right, right in the nucleus, this being the nucleus, there are particles called protons and neutrons and protons. All right, so we are saying in a relation, therefore, to this lesson, we are saying that the nucleus of an atom has a specific number of protons and neutrons. Okay? So an atom has a specific, the nucleus contains a specific number of protons, which are positive charges, and neutrons, which are not charged particles. The number of protons in the nucleus is what is called the atomic number. Remember, we are just trying to remind ourselves about what we learned about the structure of an atom in Form 1 chemistry. The number of protons, which are positive charges, in the nucleus is called atomic number. But since we are talking about the number of protons, it can also be called proton number. All right. For example, let's say, for example, we are looking at, sorry for this misbehavior of my screen. All right, let's suppose that we are looking at an atom of, say, magnesium. For example, in its nucleus, it has 12 protons, which are written down here below the symbol, and it has a mass of 24. All right, so what it means is the number of protons is going to be 12. And the number of neutrons is simply 24 subtract 12, which is also 12. So 12 plus 12 makes 24, this upper number there. All right? So the 12 is the number of protons. It is called atomic number. It is also called proton number. Why calling proton numbers? Because we are gossiping about protons here. Therefore, it is fair enough to call the number of protons proton number. Okay, like you'd say the number of students in your class. Okay, so it's fair also to call that number student number, isn't it? Yeah, it's okay. But here we're not talking about students, we are talking about protons. Therefore, it is called proton number or atomic number. So an atomic number can be represented symbolically in symbols as x raised to the power a, and down here z or z. All right. So in this case, A stands for mass number, and Z is the atomic number. All right, so if you look at an element such as, suppose we are looking at an element such as helium, for example. Helium has the symbol He and a mass of 4 and atomic number of 2. So this is mass number, and the 2 is atomic number. All right, so that's in general how it will represent an atom, which in most cases is called a nuclide symbol. So when you add up the protons and the neutrons in an atom, you find a very important and useful quantity called mass number, also called nucleon number. All right, so nucleon number, therefore, mass number is simply proton number or number of protons plus neutrons. We write this equation as A equals to protons P, which is given the letter Z, plus the number of neutrons, so mathematically like that. So you should be able to play around with this equation depending on what you are asked to find. If you are asked to find the proton number, just make it the subject of the formula. Okay, so in that case, you have Z equals to A mass number minus number of neutrons. Whichever the case, you simply have to learn to make the subject of the formula. We can also define mass number as atomic number, which is the same as the number of protons plus neutrons. So that is it for now. We have looked at the definitions of radioactivity and as the spontaneous disintegration of the nucleus of an unstable elements releasing radiations. And we've also looked at radioactive decay as a process by which an element changes into another element by emitting radiations from the nucleus. So these radiations, there are three of them. We have alpha particles, beta particles, and gamma. Take note of the symbols for each one of them. All right, so let's proceed. Now we are going to discuss each type of particle one after another. All right, starting off with alpha particles. Alpha particles are represented by the Greek letter alpha. All right, the Greek letter alpha, written like that. That's an alpha particle. You should train yourself how to write this properly. All right. An alpha particle is simply the nucleus of helium and is represented by He with a mass of 4, and the atomic number of 2. Take note that the 4 is the mass of the sum of protons and neutrons, while the 2 is the number of protons. That means we can deduce the number of neutrons helium has by simply subtracting the 2 from the 4 there. All right, so we are saying that alpha particles, an alpha particle, take note, an alpha particle is similar to helium. We are not saying helium is alpha, no, but they are just similar. In what manner similar? The helium has a mass of 4, so is alpha. Helium has 2 positive charges, so is alpha. That's what we are saying. These are just similar. Okay, we are not saying that when you see an alpha, it means you have seen a helium atom. No. They are just similar in terms of their composition. So an alpha has 2 positive charges and 2 neutrons, making 4. 2 plus 2 makes this 4 here. Similarly, helium has 2 positive charges and 2 neutrons, making the sum adding up to 4. Take note of that. So we are saying an alpha particle is the nucleus of helium, because the nucleus of helium has 4 particles. It has 4 particles, which are 2 protons and 2 neutrons, which when you add up, you get a 4, like that. Similarly, a helium has 2 positive charges and 2 neutrons, which when you add 2 plus 2, it will give you this 4 here. All right, that's very, very important to note. So let's look at the characteristics or the properties of alpha particles. First, we are saying they are positively charged. Yes, they are positively charged because they have 2 positive charges. They have 2 positive charges. Remember, we said that an alpha has a mass of 4 and it has 2 positive charges. So these 2 positive charges are responsible for the positivity of an alpha particle. So alpha particles are positively charged. They are doubly positively charged because they are 2. So there are 2 positive charges in alpha. Okay, take note. That's because of the positive 2. Okay, they are heavy and slow moving. All right, alpha particles are very heavy compared to either beta or gamma. Alpha particles are heavy. What makes them heavy is because of the mass in them. The mass. This mass makes alpha very big, very heavy. All right. You learn in physics that force on a body is directly proportional to acceleration, all right, this is called Newton's second law. It states that acceleration of a body is directly proportional to the force applied on it. All right, don't mind this one for now because it will come out clear. I just want to use this to explain a point here about the heaviness and the speed, slowness of moving. All right. All right, so we are saying that acceleration, which is the change of velocity, is directly proportional to the force. The greater the force, the faster something moves. That's very good. Now, if you make A the subject such that you have A equals to F over M, what does this tell you? This means that as the mass of the body increases, this is mass, acceleration is going to decrease. Acceleration is going to decrease. Therefore, acceleration and mass are inversely related. So why do they move slowly? It's because they have huge mass. A mass of 4 makes them to move very slowly compared to either beta particles or gamma radiations. It would interest you how much they move at the speed of 0.1 multiplied by the speed of light. The speed of an alpha particle is 0.1, which is the same as 10%. The speed of light. The speed of light is 3 times 10 to the power 8 meters per second. So we take 10% of that, you find the speed of an alpha. Very slow, eh? All right. Alpha particles are deflected by a strong magnetic field and electric field. All right, suppose that we have a source of radiation. Let's say we have a source of radiation here. Okay. If these radiations emit alpha, beta or beta, and gamma. All right. The alpha particles are observed to be deflected towards the south pole of a magnet. Suppose this is south pole and this is a north pole of the magnet. All right. So the alpha will be deflected to the south pole of the magnet. This has to do with the fact that they have a positive charge. A positive charge, when placed in a magnetic field, behaves as if it's a north pole. Therefore, it's going to migrate to the south pole of the magnet, like that. So what I'm saying is, suppose we have a magnet. Let's say we have a magnet. One end is south pole. Another end is the north pole, like that. So we have a source of radiation. All right. So we have gamma radiations, which will just pass through the field, the region between these magnetic poles, but alpha particles will be seen to tend towards the south end. Okay, because alpha, which are positive, behave as if they are a north pole of a magnet. So north and south attract. It is always the north pole that goes to the south pole. All right. Similarly, beta will tend to the north as if north is taken to be positive relative to south. So beta, which is negative, will deflect to the north pole, therefore. Very important. Similarly, here, all right, if we have a source, suppose we have a source of radiation. One end is positive. Let's say you have an electric field where one end is positive, the other end is negative. So recall that alpha particles are positive. So being positive, it means that they'll be deflected towards the negative. So positive charges always get deflected to negative ends. Here, take note. All right? And the beta, on the other hand, being negative, will be deflected towards positive because unlike charges attract. This is the principles of attraction, of the law of electrostatics. Okay? But gamma rays, which are not positive, not negative, because it's just pure radiation, will just go in straight line without deflecting either to positive end or to negative end. So make sure you know these properties of alpha particles. They produce more ionized particles along their path. As they pass through matter, they interact with matter. This is a process or a property called ionization. So another way to say is that they are more ionizing. They are most ionizing. Most ionizing. This means they turn the atoms they interact with into ions. Let's say they are passing through air. So the alpha particles will knock out electrons from air molecules, making it ionic. All right? Let's say, for example, it's made to pass through your body. Radiation is made to pass through your body. Alpha is made to pass through your body. It is going to interact with your body molecules, turning them into ions, leading to cancer, of course. All right? So, in terms of ionization, they are more ionizing than either beta or gamma. They have a low penetrating power. Hence they can be stopped by paper. Let's suppose that we have this diagram here. We have different radiations. Radiations being, sorry about the misbehavior of my screen. All right. Supposing that we have a radiation source which releases alpha, beta, and gamma. So if you place paper, like plain paper, in front of the radiations, alpha is going to be easily blocked by paper. Why? This has to do with the fact that it's heavy and it moves slowly. So alpha can easily be blocked by paper, can easily be stopped by paper. Unlike beta and gamma will pass through paper very easily, although beta can be blocked by a thin sheet of aluminum foil, as we shall see in the next slide. So we are saying the properties of alpha radiations are they are positively charged because they contain two positive charges, They are heavy and slow moving. They are deflected by strong magnetic field and electric field. They produce more ionized particles along their way, and they have a low penetrating power. Hence, they can be stopped by paper. So that was about the properties of alpha. Welcome to the properties of beta. Some say beta, but they prefer to say beta particles. So beta particles are denoted by the Greek letter B, but it's not the usual B. It's one that looks like this. All right. So beta particle. Remember that beta is also a particle, apart from alpha, which is also a particle. All right. Some facts about beta particles. All right. So a beta particle is an electron emitted from an atom. All right. Sometimes an atom can emit an electron. This process occurs when a neutron is converted into a proton. Remember that in an atom, the number of neutrons is equal to the number of electrons. So this formation, turning of a neutron into a proton, is accompanied by the formation of an electron. So it is this electron which is called a beta particle, which is called a beta particle. Right, a beta particle is represented by the symbol E. E for electron. E for electron. The symbol E is used to represent an electron. So a beta particle, we are saying a beta particle is represented by an E with a power of 0 and a charge of -1. So what does this mean? It means that a beta particle has no mass. Has no mass. If it has no mass, therefore, it is massless, and it also has a charge of -1. All right, so it has a -1 charge. That clearly gives us the difference between alpha particles and beta particles. Remember that an alpha is positively charged, so we are saying that a beta is negatively charged. Properties. All right, so beta particles are negatively charged electrons, and compared to alpha particles, they are lighter. As you might have noted in my explanation, and a beta is massless, has a mass of 0 and a charge of -1. This means no mass. Therefore, it is lighter than alpha. Remember, alpha particles have a mass of 4, all right? But beta particles have no mass. Other than that, beta particles have less ionizing power compared to alpha particles. So these do not turn matter into ions as much as alpha particles do. Okay, of course, the explanation would be that beta particles have no mass. Owing to the fact that they have no mass, it means they will not interact with matter as much as alpha particles do. Therefore, they will have less ionizing power. They are deflected by strong magnetic field and electric field. So, when allowed to pass through an electric field it means one end here is positive, the other end is negative. The beta particles will go to the positive end of the field. Why? Because they are negative. And remember, using the principle of electrostatic charges, which you learned about in Form 2, unlike charges attract, therefore beta, which is negative, will be attracted to a positive end of the field. In the same way, alpha, which is positive, as we saw already, will go to the negative end. But gamma rays, which are electromagnetic waves, will not be affected by the electric field. So it also applies to a magnetic field. If one end is south pole, another end is north pole. All right, so beta particles will be deflected towards the north pole, all right, while alpha particles will be deflected to the south pole. And the gamma rays will just pass through the field in straight lines without being deflected. All right, in terms of penetration, beta particles are highly penetrating compared to alpha, but they can be blocked easily by aluminium foil. They'll pass through, they'll be blocked by aluminium foil. They'll pass through paper quite all right, but they'll be blocked by aluminium foil. So they penetrate through paper but are stopped by thin aluminium. Make sure you know these properties of beta radiations. All right, would like to proceed to look at the gamma rays. Remember that gamma is an electromagnetic wave. Unlike alpha and beta, gamma rays are electromagnetic waves with very short wavelength and very high frequency. If a wave has very high frequency, it means it has more energy. All right, so owing to the fact that gamma rays has high frequency, it means they are high energy radiations also. All right, so if they have high energy and the high speed, it means that they can easily pass through matter like paper, aluminium foil, but it requires just some centimeters of lead metal to be blocked. All right, properties of gamma rays. They have no mass and no charge. They are not particles, So there's no way they can have mass, they can have a charge. It's not a particle. Because only particles have mass and charge. And apart from having no mass and no charge, they are electromagnetic waves. I'm sure you have learned about electromagnetic waves. There are 7 of them. We have radio waves, microwaves, infrared, visible light, UV radiation, X-rays, and the gamma. There are 7. All right, so gamma, this one, has very high frequency and very high energy and very high speed compared to the others. Why? Because of the high frequency. All right. Okay. So they are electromagnetic waves. As all electromagnetic waves, they have a speed of 10 to the 3 times 10 to the power 8 meters per second. All right. They are not deflected by both magnetic fields and electric field. Why? Because they are not particles. The fact that they are not particles, they are not affected by either electric field or magnetic field. All right, they cause little or no ionization at all. Why again? Because they are not particles. So since they are not particles, they don't interact with matter which they pass through. They can pass through paper and the aluminium foil, but they can be stopped by thick lead. So these are the properties of electromagnetic wave called gamma rays. All right. In case you have questions, don't hesitate to leave your question in the comment section. It will gladden my heart quite a lot to respond to your questions. Don't forget also to like the video, share the video, invite your friends to join us to learn here. You can also enroll into our online lessons so that you receive lessons directly into your classroom. All right, so once again, my name is Mr. Poch Lola, your teacher. All right, before I go, I would like to leave this exercise with you. All right, in the figure below shows radiations in a magnetic field. So we have as a radioactive source here, the magnetic field is perpendicular to the paper and directed out of paper. Okay. Identify the radiations marked A, B, and C. All right, don't mind these answers, just write your own. So observe carefully. If they're coming out of paper, if the perpendicular directed out of paper, it means one end is north. Maybe I should give you a hint. This is North Pole, and then we have a South Pole. Okay. All right, so what is A, B, and C? So based on the discussion we just had, you should be able to tell what A is, B is, and so on, without explaining the reason why. Number 2, the figure below shows a narrow beam of radiation from a radioactive source incident to a postcard. So we have a postcard here. The emergent radiation passes through the magnetic field, which is perpendicular to the plane of the paper and into the paper. A detector moving along the line PR detects radiations only at point Q. All right, state the radiations that could be detected at Q. All right. So postcard is a paper, therefore it means the radiation will pass through and it will travel in straight lines. Okay? And it will be detected at Q. But the radiation is also going to be deflected, given that this end is North Pole and this end is South. Some radiation deflected this way. All right. State with the reason the radiation is not detected. All right, not detected. Not detected. Okay, so such radiation should not go beyond the paper. Okay, so it's only two radiations that will pass through the card. Card is paper. It blocks some radiations and allows some others to pass through. So that radiation which is blocked by paper is what? All right. So I would like you to write this homework properly and share with me the answers to the number that I shared earlier on the first slide. My name once again is Mr. Poch Lola. I want to thank you in a special way for paying attention. I'm so excited to be your teacher, and I look forward to having you pass your exams very well and pass with no less than a distinction, which is 2. All right. Thank you very much. Bye-bye for now. Meet you again in the next lesson.